Today we are going to do the problem number 6.5. Now in this problem, what we are looking at is we are assigning a service centers for the United Copier company. Now United Copier company, they are selling their devices, or they are selling their machines to 11 cities in the country, and these 11 cities are here. So if you see in the table, it's clearly given that there are basically 11 cities, and distance between each cities is given in miles. So you will see that distance between Chicago and Boston is 983, and while likewise Boston and Dallas is 1815, and Denver is 1991. So it's given like they have given you the complete distance between the two cities. Also, they have given you the number of services that our service man goes to the particular city. So, for example, if the company sends its serviceman to Boston 885 times in a year. Likewise, they send 760 times a year in Chicago, or 1124 times to Dallas. So basically, they are sending their service people to these cities in various number of times. Now the company wants to organize a service center. So basically, they are trying to organize 3 service centers, just as per the question. It says they want to identify 3 places where they could set up a service center in order to minimize the travel between the cities. So these centers will also assist other cities. So let's say, for example, if we have a service center in Boston, it can do services to all the other cities. However, we can also have let's say a distance between Boston to Dallas is more than distance between Chicago and Dallas. So if you have a service center in Boston and if you have a service center in Chicago, it's more feasible to send a service guy from Chicago because it's less distance than Boston. Or else if we have someone in Denver, for example, then it's even better. So this is the question all about. So we need to identify the shortest distance first of all, and the lowest miles used by an individual by the company to cater to the requirement. So we will, in this problem, we will first identify 3 places where the service center should be allocated in order to minimize the total miles by the company based on the estimated a number of annual trips to the customers. Then in further enhancement to the problem, we will identify what exactly needs to be what further needs to be done if, let's say, for the company decides what is the impact of having 4 service centers rather than 3, or what is the impact of 5 service centers rather than 3. Then also I would enhancement, which is not necessarily given in this problem, I would also still do we would still do to understand the cost involved, cost impact due to just to roughly to estimate how the cost will change if this we will come to understand that point. I will explain you the point what I am trying to tell you. So the Excel sheet model is right here. So this is the main model wherein we just copied pasted the distance between the cities here in miles, and these are the locations where we would like to have our we would like to have our service centers at this point. So we will put 1 if our service center is located in this area. Here we will put 0 if not. So let's put 1 for now in all the cities. So now we have 1 in all the cities. So likewise, we will definitely want to put the services where it will be applicable. So if, let's say, for right now there is Boston, so there will be 0 distance. I mean, you don't have, if there is a request from Boston, you don't have to go from Boston. So right now it's a 0, but you can always put 1 or whatever number, but it has to be 1. So what it is trying to identify is, if the request comes from Boston, we will put 1 from the city where it is serviced from. So it has to be necessarily match where the service center is available. So let's say now I'm not putting all 0, 1. I'm just, for the explanation purpose, I will put 0, 0, 1, 0, 1, 0, 0, 1, 0, 0. So now let's see. So if I have to service from Boston, for example, which is the nearest service center, which is where it can go. So I will have to look into this column, Boston, and check for the lowest one. So one service center is in Dallas, which is 1815, which is higher. Then the other one is in no, I don't have in Denver. I have this is even higher, 3036. And then the other one I have in Phoenix, which is 2664. So, and one is in Seattle. So basically I would prefer Dallas in this case. So you will see now I have total assignment is 1, and it is very essential that I will have 1 assignment in for every city. So Boston cannot go into 2 centers in this case. So we will have 1 center in that case for every given locations. So likewise, if you see again Chicago, the nearest would be Dallas or Los Angeles. It's 2112, and then I will have and then the next one I have, it is in Phoenix, which is again Chicago 1729, and I have Seattle. So basically again it will be Dallas. Very nice. So let me put 0 for everybody first of all, so that it's more simpler for us to know. Then I have is Dallas. Dallas, of course, Dallas would be the cheapest, because the smallest, because it's the place where it is. And then I have Denver. Denver, of course, I will be closer. Denver is here, and closest to Denver is Dallas 801 1174. Phoenix is 836, and I have 17. So basically it will be again Dallas. Wow. Then having Los Angeles. Los Angeles is very far away from Dallas, and I have Phoenix, which is Los Angeles is 0, so of course it will be in Los Angeles. Very nice. Then Miami, it will be closer to Los Angeles 2757, Dallas 1332, so it's clear closer to Phoenix 2359. Again it's Dallas. Wow. So New York. So if I will have to put New York, but so I clearly see that you got the idea of having the service center. So likewise, now once we have the services, we are going to calculate the total distances that it is going to travel. So I have got 885 total trips from Boston, and I know for the fact that Boston has to be serviced by Dallas. So what I'm doing is I'm doing the sum product of this times the this. So if let's say 0 times 0, 0 times 983, 1 times 181.5, so times so this is for the one trip from Dallas to Boston. Now I need 885 such trips, so times 885 divided by 1000, so I will get per 1000 miles. So then I'll copy this formula till the end, and I get the total distance for each city that will be traveled, and this is the sum of the total miles. So this will complete our template. Now I will run the solver. So let's start the solver. So when I start the solver, I have to will reset all first. Then I will do is I want to minimize this as per the problem by changing, because I have to identify total number of service centers along with how these service centers are allocated. So basically we will identify where the service centers are located and which city is serviced by which service center in order to minimize our objective functions. Then I will add the constraints. The constraint is I need this service center to be equal to the max service centers as requested by the company. I will also have one service center assigned for each city. So I cannot have more than one service center assigned to each city. Really? Okay. Okay, so this has to be 4. Then I can only add 1 and 0 to these numbers, so I cannot have any different numbers. So I will only have one number, a 1 or 0. Then I will also make sure that I do not exceed the number of cities in per, so this will help me to give you proper arrangement. So what I'm saying is, why am I doing this is to make sure that if the service center is not located in Boston, there shouldn't be any allocation in the Boston, so it has to be equal to 0. So okay, that completes my model. Anyways, if I leave this non-negative, it doesn't make sense, so it is not a problem. And I will make this optimality percentage to 0, so to make sure that I will get my correct answers. So let's see. There you go, the model completes. So this is where, so I have 3 locations, which is Dallas, New York, San Francisco. These are the 3 places where I will locate my service centers, and accordingly I have Boston being allocated to New York, then Chicago being allocated. So you can just imagine the headache of work that I have to do in order to identify the lowest of all the arrangements in this problem. So let's study if I have to change the number of service centers that I am allocating. So that has been already done. I have done through solver table. So we just identify the, if let's say I have one service center, the minimum would be 15,202,000 miles. For 11 service centers, of course, it will be 0. So the 11 service center means each city will have its own service centers. 1 means only one of the 11 cities will have the service centers, which is basically center of all. So, and if you see, optimally it goes reducing, and it is going to reduce. So, but this is not logical. Okay, so definitely if you increase the number of cities, definitely you will have less and less miles. But you can see the change is coming little. So the graph is drastically reducing when you have 2 and when you have 3, but it kind of goes, the percentage of decrease in the miles goes less and less. So this tells us that we should look into the cost function of installing or setting up the new or managing the service center. So maybe the difference here that we are getting by adding new service center is much less than the cost involved to maintain that service centers. So for that purpose, I just created a small setup wherein I have just hypothetically added a value of $15 cost per miles, and I have also hypothetically understood the cost means it involves the traveling costs, fuel and all that stuff for traveling 1 mile, that's 15. So unit mile, cost per unit miles, it will be unit, and this will be the annual cost of operating or maintaining the service center, which is $25,000. So total cost would be nothing but 15 times the number of total distance, and this times the number of service centers. So what you will get is the total cost. Now what I have done is to evaluate the solver table used to understand the differences in cost if you change the number of service centers. So if you have one service center, based on the hypothetical cost, I will get 253,000 total cost, wherein this cost comes down initially and then it starts to pick up again. So the lowest is at three service centers. So this gives us an idea that if you have more than 3 with the same cost structure, or if the cost structure is known, for example, the total cost starts to rise. So the lowest cost would be 3 particularly. Now this also, we can also go through another solver table by changing these numbers and have an idea of what is the optimal unit cost per mile and what is the optimal unit cost for setting up. So but this is still estimates and can be varied according to our model. Further, to understand, I have also tried to go into detail of how, if for example Boston has got a request of 985, wherein some has got 1560. So then there definitely for particular service center there is a capacity limitation as well. So if they can only service n number of customers, so which means this calls for another, what if I will allow a minimum for a service center. So we have a service center and we want to make sure that at least 2000 or 2500 customers are serviced, otherwise there is no point in having a service center in that area. So for that reason I have put a limitation, or in order to further make sure that some service centers are not going to be overloaded and some service centers. So if I don't put this, for example, and then I have I would rather see if I will minimum is 0, and then if I will run solver again, but this time I'm going to minimize this again, and I will have the same conditions and I will run the solver. Okay, I'll have to reset it all again, so because that's I maintained for the other part. So I will have this by changing this and this, and this has to be minimized. I will add conditions. So this is new. I'm going to add this should be greater than or equal to this. Now let's see and solve the problem. Wait, there's something wrong. So this is the first one. Delete. First constraint is I need this to be equal to binary, and I need this to be equal to binary, and I need this to be less than or equal to this. I need this to be equal to this. This to this. Okay, so basically the model has been spoiled up. Okay, so now and data's over. Okay, sorry for the inconvenience. So again, we need to run the solver, and the mistake is here. So we need to change this, and hello, that's it. So now we got the right answer. So now the solution is still the same, so 5145. But if I will change this to 2500, because you see that New York is serving to 5213, and San Francisco, we're having a Dallas, is like 1832. So I am putting a limitation that I want to have 2500 per service centers. Then in that case I will have a different answer, which is still close to the optimal, that is 5230. So, but in this case, now I have 2984, and so I will limit things up. Let's say I have 3500. So then I will run this over again. I still have to travel 5798, and I will get 3500 in each of them, close to 3000. So I'm optimally using all my service centers properly without overloading one per service center or the other.